So as you see this thing rotating and coming to a stop, it's right at about 1.040. So it's going to bob up and down a little bit, but horizontally you're going to see it level off at that mark. How's it going, guys? And in this video, I'm going to be talking about specific gravity, and this is a measurement that helps people understand the alcohol content in their beer when they're doing a fermentation. This applies to other liquids too, but I've just been doing a homebrew and we've been making use of the specific gravity to determine what the final ABV is, or the alcohol by volume of our product. And so it uses this instrument called a hydrometer. It's literally just a glass tube, and at the base of it you've got some weight, and the rest of that tube is filled with air. And so when you put this tube into your wort, it's going to experience a buoyant force that helps push it up. So a very dense liquid will have a much stronger buoyant force with not as much volume displaced. Consequently, if you had a super dense solution, that hydrometer is not going to go that far. Whereas if you had a really not dense solution, the hydrometer will sink a lot deeper. And so basically what you look for when you're measuring with these hydrometers is to see how deep this thing goes. And so there's a little piece of paper inside that hydrometer with a bunch of numbers on it. And as long as that piece of paper stays constant, that's all you really care about, because what you want to see is how the height of this thing changes between the start of your fermentation and the end of your fermentation. So just when you pitched your yeast into your wort, that's when you take that OG, or original gravity measurement. And then once your yeast finished fermenting, when they stop making those bubbles, that's when you take your final gravity measurement, your specific gravity again with that hydrometer, and you look at the difference between those two. And so what you expect to see when you do this process is that the specific gravity will get lower and lower, which means that solution is becoming less and less dense. The reason it's becoming less dense primarily is because the yeast are taking all of the sugar that's around them and they're consuming that and turning that into ethanol. And so as they do that process, they are changing the concentrations of those species, and that has the impact of changing the density of the actual fluid. And so by measuring the OG and the FG, there's a formula you can apply, and it lets you know what the ABV is at the end of the day. And that formula is 132.715 times the quantity of the original gravity minus the final gravity. And so I'll show a clip in a little bit of what it looks like. But when you are measuring your specific gravity, you're going to pipette some of your wort out of your carboy, because you don't want to do this inside that carboy. You want to minimize contamination. And so you're going to pipette this liquid, put it into a graduated cylinder, and then once you've got enough liquid in your graduated cylinder such that the hydrometer is able to float up and down and not hit the bottom, then you've got enough in there. And then what you'll do is you'll spin the hydrometer just a little bit, and that helps it kind of stop bouncing up and down vertically, and it helps stabilize it horizontally. And then once it does that and it slows to spin, you can then read off on a little piece of paper inside that hydrometer what that specific gravity reading is. Another thing that's very important to note here is that if you're really trying to be super precise, it is important to note that if you had pure water at the specified temperature for that hydrometer, you should have a specific gravity of 1.000. And so if you want to calibrate your hydrometer, just for the sake of seeing what it's like, you need to make sure you've got the right temperature inside that room. So you're gonna need a thermometer somewhere. And then once you do that, you take your water, put it in that graduated cylinder, check if you're actually getting a true reading of 1.000 with pure water. And then once you know that that's good, then you can move on to your wort and then see what that returns. And so that's a very important note to make, because the density of liquids changes as a function of temperature. So it can throw off your specific gravity readings by a little bit. So that's an introduction of errors in if you're ever doing some kind of write-up on this. But that's important to note. And so yeah, so just key thing again, so over time, the density of your wort, of that sugar solution that you prepared just before you started your fermentation, is going to decrease because it's losing that sugar and it's being replaced with ethanol. So those complex sugars or denser sugars are getting substituted for ethanol, which is a lighter component, and that's making that density of that liquid a lot less. So I'm going to wrap things up with that. I'll show you guys what the clips look like in terms of how to read this off. Typically, you're going to see like 1.000 is like this big bar, and then you'll see 10, 20, 30, 40. So if your liquid is at like the 40 mark, then that means that it's 1.040. And so that's how you would read that. And the numbers would be descending like this. So over time, what you're going to see if you had your hydrometer in this as the specific gravity was decreasing, your hydrometer will actually sink more and more because that solution is getting less and less dense and it's letting it sink just like that. A final note I'll make is that in terms of a ballpark figure, if you're doing beer, your wort typically will have a range of 1.030 to 1.070 for your original gravity, and then the final gravity readings sometimes can be around 1.01. So just ballpark figures. Sometimes there might be a crazy amount of sugar present, which would really increase your specific gravity, but that's what to look for. So hope this helps. Thank you all for watching. Let me know if you have any questions. Talk to you guys next time.